Alcohols are classified mainly into two categories, that is based on number of hydroxyl groups and based on hybridization of carbon atom. In number of OH groups category, depending on the number of OH groups, that is 1, 2, 3 or many hydroxyl group, we have monohydric alcohols, dihydric alcohols, trihydric alcohols and polyhydric alcohols. In second category, that is based on hybridization of carbon atom, there are two subcategories, that is OH group on sp3 hybridized carbon atom and OH group on sp2 hybridized carbon atom. Alcohols with hydroxyl group on sp3 hybridized carbon atom is further divided into degree of substitution of carbon atom, allylic alcohols, benzylic alcohols, wherein degree of substitution of carbon atom we have primary, secondary and tertiary alcohols. Hydroxyl group on sp2 hybridized carbon atom is further divided into vinylic alcohols and phenols. On classifying alcohols based on number of hydroxyl group, firstly we have monohydric alcohols which contain one hydroxyl group per molecule. Example, ethyl alcohol, propyl alcohol and many more. Dihydric alcohols contain two hydroxyl groups per molecule. For example, ethylene glycol, 1,3-propanediol and many more. Trihydric alcohols contain 3 hydroxyl groups per molecule. Glycerol and trimethylopropane are some examples. Polyhydric alcohols contain more than 3 hydroxyl groups per molecule, that is glucose, sorbitol and many more. We have in di, tri or polyhydric alcohols, OH group are attached to different carbon atoms of the same molecule, whereas two or more hydroxyl groups cannot be attached to the same carbon atom in one molecule. In category hybridization of carbon atom, in which hydroxyl group is on sp3 hybridized carbon atom, the first subcategory is degree of substitution of the carbon atom. They are also called as saturated aliphatic monohydric alcohols. This category is further subdivided into primary, secondary and tertiary alcohols. Primary alcohols in which OH group is linked to primary carbon atom, that is the carbon atom which is attached to only one carbon atom. In secondary alcohols, OH group is linked to that carbon atom which is bonded to two other carbon atoms in the same molecules. Tertiary alcohols are the one in which OH group is on the tertiary carbon atom, that is the carbon atom which is linked to three different C atoms of the same molecule. In the category hybridization of carbon atom in which hydroxyl group is on sp3 hybridized carbon atom, the second subcategory is allylic alcohols. Here the OH group is on allylic carbon atom. Allylic carbon atom is the sp3 hybridized carbon atom which is next to a sp2 hybridized carbon atom. That is, the allylic carbon atom is the one next to a double bond in a molecule. The third subcategory is benzylic alcohols. Here OH group is on the sp3 hybridized carbon atom which is directly attached to a benzene ring. Category of alcohols in which hydroxyl group is on sp2 hybridized carbon atom, the first subgroup is vinylic alcohols. That is, OH group is attached to sp2 hybridized carbon atom. That is, the carbon atom linked to another carbon atom with a double bond. The second category is phenols. In phenols, the hydroxyl group is directly linked to sp2 hybridized carbon atom of benzene ring.